You are welcome once again. In our last topic, we talked about direct variation, where as one quantity increases, the other also increases. Now, look at this situation. Somebody is traveling down here from South, maybe Ughelli, to somewhere in Ondo. The journey might take at around maybe 6 to 7 hours of driving. But the driver of the vehicle cruises at a much higher speed than normal. What do we expect? He might get there much lesser than 6 hours. So as the speed increases, time reduces. What about this other situation? You want to build the foundation of your house. You decide to call men to come and work on it. But you choose to call two to build the foundation of your house. And you expect them to finish building the foundation within 3 days. Is that practically possible? The answer is no. Because the hands are few, the time taken to complete the job will be more. With this, I welcome you to the topic for today, which is inverse variation. As we have seen from the two examples that I cited not quite long, as one quantity goes up, the other quantity comes down. If two quantities x and y relate inversely, they are written as x is inversely proportional to the reciprocal of y. That is how inverse variation is written. Now let's see some worked examples on how we can solve problems involving inverse variation. Number one, given that n varies inversely as d raised to the power 3, and that n equals 240 when d equals 3. Find n when d equals 2. Now let's look at it. The first thing we do, first step, identify the two quantities. As we can see from the question, n varies inversely as d raised to the power 3. So the two quantities here are n and d raised to the power 3. So let's write how they relate with each other. So that will be n varies inversely as d raised to the power 3. The next step is to introduce k, our constant. This will now be n equals 1 over d raised to the power 3 times k, which is also the same as saying k equals d raised to the power 3. We will now look for the value for k by cross multiplication. Let's look for the value for k by cross multiplication. If we cross multiply, k will be equal to n times d raised to power 3. Having made k the subject of the formula, the next thing here where we introduce k, we say where k is a constant. Don't fail to mention this place. So in the question we are given two values for n and d. The purpose of those values is to help us find k. So when n is 240, when n is 240, d is 3. Let's substitute them here. Therefore, k will be 240 times 3 raised to power 3, which is the same thing as saying 240 times 27. 3 raised to power 3 means 3 multiply itself 3 times. So 240 times 27 is 6,480. That's our value for k. How do you obtain the value for k? The next step now is to get our law of proportionality. You recall that point we introduced our k. We now substitute the value for k here. N will now be what? 6,480 over d raised to power 3. This is our law of variation. It's our law of variation, or the relationship, or the law that is the relationship between n and d raised to power 3, or the law that is connecting n and d raised to power 3. These are some other expressions that can be used in place of law of variation. Now let's find what we are asked to calculate for. We are asked to find n when d equals 2. Find n when d equals 2. So when n, we don't know, and d equals 2, from question asterisk, we have that n equals 6,480 over d raised to power 3. That will be 6,480 over 2 raised to power 3. Of course, this will be 6,480 over 2 raised to power 3 means 2 multiply itself 3 times. That will give you what? 8. Now if we divide 8 here, 1, 8 into 64 is 8 into 8, 1 into 0, 0. So therefore the value for n is 810. You see inverse variation here. When it was T4, when n was 240, d was 3. Now n has increased to 810. The value for d is what? 2. So as one quantity goes up, the other comes down. Let me give you a few seconds to put this down. Let's look at another example. 2. This one is more practical as it affects our day-to-day living. A road contractor estimated that it will take 400 men (27 months) to build a motorway. He reckons that the time taken to complete the job is inversely proportional to the number of men employed. A. How long would it take to build the motorway when there are 200 men, or with 200 men? B. How many men would it take to complete the job in 2 years? So let's look at the question again. A road contractor, let me just A road contractor estimated that it would take 400 men 27 months to build a motorway. He reckons that the time taken to complete the job is inversely proportional to the number of men employed. A. How long would it take to build the motorway with 200 men? B. How many men would it take to complete the job in 2 years? When students see this kind of question, they say, hey, how are we going to do this kind of thing? Don't be afraid. Just follow the principles we have been using, and it's as easy as eating your plate of rice. Let's go. First, identify. I guess you have taken down the questions now because I'm going to clean the question. Identify the two quantities that are related to each other. Let's start from here first. Let's identify the two quantities. A road contractor estimated that it would take 400 men 27 months to build a motorway. Do we see any two quantities that are related there? Somehow yes, but more plainly no. You see the reason why I say somehow yes. Let's go ahead. He reckons that the time taken to complete the job is inversely proportional to the number of men employed. Here, it is more clearer now. Time taken and number of men. You see the reason why I say somehow yes, we are giving 400 men 27 months. So we are giving a clue already at the beginning. But here it is now very clear. The time taken and number of men. So first of all, let's attribute some variables to this statement. So say let the time taken equals T, let the number of men equals N. So let's write how they are related to each other. Let's write how they are related to each other using the sign of proportionality. So that's time taken is inversely proportional to the number of men. That is it. So let's introduce our K. To introduce our K, this will imply T is equal to 1 over N times K, where K is a constant. Where K is a constant. So here, this is the same thing as saying T equals K over N. If we cross multiply so that we can make K subject of the formula, we are going to have K. Sorry, let's cross multiply. We're going to have K equals T times N. So now let's use the first set of values we are given to solve. We are told that when there are 400 men, it will take them 27 months. So where N equals 400, T is 27. T is 27. T is 27. So let's substitute them here. So therefore, K is going to be 27 times 400. 27 times 400, if you multiply the two, you get 10,800. So the value for K is 10,800. Having obtained K, the next thing we'll do now is to write out the law of variation, or the law or relationship that is connecting T and N. Here, do we recall? What do we recall? The point where we introduce our value for K. Recall what? That T equals what? K over what? N. So that is going to be, if we now put our values for K there, therefore means that T equals 10,800 over N. Yes. This is the relationship that is connecting T and N, or the law of the ratio. Now, with these two in our hands, we can now solve the two questions that will be asked. Question A says, how long would it take to build the motorway when there are 200 men? So, when question A, when T, we don't know, N is 200, what do we do? Let's come here. From this equation, where T equals 10,800 over N, we substitute our value for N there. Therefore, T will now be 10,800 over 200. 0, 0, 0, 0. 2 here, 1. 2 into 10, into 10, 5 into 8, 4. So it will take what? 54 months. This 54 months is about 4.5 years. It's about 4.5 years. Let's look at question B. Let's look at question B now. Question B says, how many men would it take to complete the job in 2 years? So here, number of men, we don't know. Time is 2 years. Remember, our information initially was given in months. So we are going to convert these 2 years to months, which is what? 24 what? Months. When solving problems in mathematics, our units must be uniform. So we are going to use 24 months. So still using the law that is connecting time taken and number of men. Where we have T equals 10,800 over n. Here our T is 24. That's 10,800 over n. If we make n subject of the formula, n replace 24, 24 will come here. I know you know how to do that. N will be equal to 10,800 over 24. So let's cancel out. Let's cancel out. 2 years 12, 2 years 5,400. 6 years 2. 6 years is 900. That will be 900 over 2. 2 years 1, 2 years 450. So it will take how many men? 450 men. Yes. So do we see inverse variation here? Initially, when there were 400 men on site, it will take them 27 months. Now, when there are 200 men, a fewer number of men now, it took them how long? 54 months. As we got from the calculation of question A, 54 months, that's about 4.5 years. But now, when there are 450 men on site, how long did it take them? 24 months. So the more the hands, the lesser time it takes to complete the job. That is inverse variation, as simple as eating pie. It's as easy as that. I know you can do it too if you follow these basic steps or approach we have used in solving direct and inverse variation. As you may have observed, the steps we follow are the same for direct and inverse variation. In our next video, we'll be looking at joint variation, a combination of direct and inverse variation. Please join me in that video. Thank you very much. Don't forget to press the subscribe button and press the notification bell so that you'll be informed when a new video has been released. Thank you, and I wish to see you next time.